Hey there, CJ Masters. I'm going to walk you through notes 5.9. Basically what we're going to do today is discover that sometimes equations are nice and neat and have one solution, like x equals 3. That's what we've been working with. But sometimes equations have infinite solutions, or all real numbers, where any number is a solution, and then sometimes they actually have no solution. So number 1 is pretty straightforward. I'm going to go ahead and walk you through number 2. I would highly recommend pausing and then trying a problem, because there's multiple steps on these problems and it can be confusing when you do it on your own. So here we're going to solve by subtracting 2x from both sides. You can subtract today because I don't think there'll be any negatives. So 5x plus 5 equals 55. And then obviously we subtract 5 from both sides. Sorry, those cancel out, right? So 5x is equal to 50. After you divide by 5, you get x equals 10. So now they want you to do is plug in and check to see that 10 is the answer. So you have 7 parentheses 10 and 2 parentheses 10. Instead of x, we plug in 10. So this is 70 plus 5 is equal to 2 times 10, 20 plus 55. 70 plus 5 is 75. 20 plus 55 is 75. So we know we have the right answer. So is 13 a valid solution? That's false. The only valid solution is 10. Because we just checked to see that both sides are equal. When you plugged in 13, both sides would not be equal. All right. So if we get something that just says like x equals 10 like we just got, that has one solution. That's basically saying if there's a variable left on one side and a value left on the other side, it has one solution. So we're going to go ahead and try and see if these equations have one solution or multiple solutions. So here we have 6x plus 10 equals 6 plus 6x. If I subtract 6x from both sides, my variables are actually going to cancel out. There's no such thing as 0x, and I get 10 equals 6. This is an example of no solutions, when you have two numbers that in the end that don't equal each other. So we're not going to check that one. Here, if I subtract 4x from both sides, again, my variables will cancel out. I get 8 equals 0. So again, we have no solutions. On this one, and if I combine my like terms, since they're on the same time, I get 13x plus 8 equals 9x plus 8. 9x, sorry, minus 8, my bad. And then what I can do is subtract 9x from both sides. I'll get 4x plus 8 equals negative 8. And this is a two-step equation. This will give me a solution, right? I get something like 4x. When I subtract 8 from both sides or add negative 8 to both sides, I get 4x equals negative 16. That gives you one solution, right? Here, when I subtract, I'm going to get something left with 19 equals 68. So that's no solution. So basically, if your variables cancel out, you're going to be left with two options: no solutions or infinite solutions. And in this case, a lot of these have no solutions. So I'd pause right now and try and do number 4 if I were you. Number 3 is pretty straightforward. All right, number 5. When I subtract 4 from both sides, these both cancel off, and I'm left with 7x equals 7x. Another way to think about it is the way we've always been doing it. It's to move the variables first. And when I move the variables, oops, this should be a plus sign. When I move the variables first and I subtract 7x from both sides, notice the difference this time. They cross off. I have no variables left, but this time 4 equals 4, which is a true statement. 4 is equal to 4. So therefore, I have an infinite amount of solutions. No matter what I plug in for x, everything will be a solution. So it's true that 7 is a solution. It's true that 44 is a solution. If I plugged in 1,688, it would be a solution. Number 6, we're going to solve for x. So first, let's combine like terms. And we're going to write this up over here. 10x minus 3 is equal to, combine these like terms, and it's basically, I'm left with 10x, and then negative 9 plus 6 is negative 3, so minus 3. Sorry, forgot my x. Whenever you get to this situation, you don't even have to work out a problem. If you have two expressions that are equal to each other, you will always have infinite solutions. If they mirror each other in any way, they'll be infinite solutions. And we can prove that by subtracting 10x from both sides, subtracting 10x from both sides. Those cancel out, and look what I have. I have negative 3 equals negative 3, right? The infinite solution. So I'm pretty sure you're going to want to select infinite solutions. On your homework, infinite solutions is all real numbers. That's how they say it. These mean the same exact thing. All right, one last one. We're going to first simplify 6x plus 6 equals 9x plus 6 minus 3. So This side, there's nothing to simplify. It just stayed 6x plus 6. This side, you have like terms. 9x minus 3x is 6x plus 6. And look, this is exactly what I was talking about, where both sides of the expression are exactly equal to each other. They're the exact same. I could prove this mathematically by going ahead and subtracting 6x from both sides. And I'll get 6 equals 6, right? So we know we have infinite solutions, right? So I'd pause again, make sure you've done 1 through 7, and this is the end of part 1.